Somewhere, in the depths of cosmic time, there is something so vast, so impossibly massive, that our minds struggle to grasp it. It is older than the Earth. It is brighter than 100 trillion suns. It is heavier than every star in our galaxy combined. And it has been waiting patiently for us to find it. Its name is TON 618. Tonight, we will travel to it. Across more than 10 billion light-years of empty space. Back through cosmic time, to an age when our own galaxy was still forming. To a place so far away that the light we see from it tonight began its journey before the Earth even existed. TON 618 is a quasar, a blindingly bright object powered by a supermassive black hole at its center. But this is not just any black hole. It is one of the largest black holes ever discovered, with a mass somewhere between 40 and 66 billion times the mass of our Sun. To put this in perspective, every star in our Milky Way galaxy, every single one of the 100 billion stars you cannot see from Earth, would not, all combined, equal the mass of TON 618. This one object, this one heart of darkness at the edge of cosmic time, outweighs an entire galaxy. Its event horizon is so enormous that if you placed it at the center of our solar system, it would extend 40 times beyond the orbit of Pluto. Light, traveling at 300,000 kilometers per second, would need weeks to cross it. And yet, for nearly a decade after its discovery, astronomers thought it was simply a faint blue star. Tonight, we will follow the strange and beautiful history of TON 618. From its accidental discovery in 1957 on a photographic plate in Mexico, to the moment astronomers realized what it truly was. We will explore the nature of quasars. We will stand, in imagination, at the edge of this colossus. We will look back through cosmic time to see what it tells us about the early universe. And we will follow it forward through impossible spans of cosmic future to the moment many billions of trillions of years from now, when even TON 618 will finally fade away. There is no rush tonight. There is nothing to fear in this story. Just close your eyes, or let them rest gently on the screen. Let your breathing slow. The cosmos is patient. It has waited 14 billion years to teach us about its largest and oldest objects. It can wait for us a little longer. Welcome to Sleeping Galaxy. If you're new here, you can subscribe to drift through the cosmos with us each week. Tonight, we travel to TON 618, the largest black hole ever known. Our story begins in 1957, in Mexico, high in the Central Highlands, about 11 kilometers west of the city of Puebla. There is an astronomical observatory. It sits on a small hillside at the foot of the Popocatépetl volcano. It is called the Tonantzintla Observatory. Its name comes from the Nahuatl language. Tonantzintla means place of our little mother. The observatory is small. By the standards of modern astronomy, it is almost humble, but it has a quiet, important place in the history of cosmic discovery. In the 1950s, two Mexican astronomers, Braulio Iriarte and Enrique Chavira, began a survey of the night sky. They were using a small telescope, a 0.7-meter Schmidt telescope, designed for photographing wide regions of the sky onto large glass photographic plates. Their goal was specific. They were searching for faint blue stars, particularly white dwarfs, in the regions of sky far above and below the plane of our Milky Way galaxy.
White dwarfs, as we have learned, are the small, hot, dim cores of dead stars. They glow with a bluish-white light. From Earth, they appear as faint blue dots. Iriarte and Chavira were cataloging these dim objects one by one. The survey took years. Night after night, the photographic plates accumulated. The astronomers carefully examined each plate, identifying the blue dots. Each was given a number. Each was added to what would become known as the Tonantzintla catalogue. And one night, sometime in 1957, they recorded a particular faint blue object. It was, in their words, decidedly violet, slightly more blue, slightly stranger than the others. They added it to their catalogue as entry number 618. They called it TON 618. To them, it appeared to be just another distant white dwarf, a small, dead star somewhere in our galaxy. They had no reason to suspect otherwise. It would take 13 years before anyone realized what TON 618 truly was. The reason for the delay is simple. In 1957, the very concept of a quasar had not yet been invented. The story of how quasars were discovered is itself remarkable. In the late 1950s and early 1960s, astronomers began studying mysterious radio sources in the sky. Strange, intense radio signals were coming from points that, in ordinary visible light, looked simply like stars. But these were not stars. They were too distant, too luminous, too strange. In 1963, the astronomer Martin Schmidt, working at the Mount Palomar Observatory in California, made a critical observation. He was studying the spectrum of an object called 3C273, one of those mysterious radio sources. He noticed something the others had missed. The emission lines in the spectrum were shifted dramatically toward the red end of the visible light range. This redshift was so large that 3C273 had to be incredibly distant, billions of light years away.
And for it to appear as bright as it did at such an enormous distance, it had to be one of the most luminous objects ever seen, more luminous than entire galaxies. The discovery shocked astronomers. What kind of object could shine so brightly? The term quasi-stellar radio source was coined. Soon, this was shortened to quasar. By the late 1960s, quasars were a major topic of study. Astronomers began looking for more of them. They began re-examining old photographic plates, comparing the catalogued objects to the new radio observations. And in 1970, 13 years after TON 618 was first catalogued, something remarkable happened. A radio survey was being conducted in Bologna, Italy. The astronomers were systematically observing the sky, looking for sources of radio emission. And they detected radio waves coming from the exact position of TON 618, a faint blue star that had been sitting in a catalogue of white dwarfs for over a decade, was now revealed to be a quasar. An extraordinarily distant, extraordinarily luminous object. Not a nearby dead star at all. Not even a star.
it was something else entirely. Soon after, the astronomer Marie-Helene Ulrich obtained optical spectra of TON 618 at the McDonald Observatory in Texas. Her observations revealed the typical emission lines of a quasar, and from the redshift of those lines, she could calculate the object's distance. TON 618 was about 10.8 billion light-years away. This was almost incomprehensible. The light that we see from TON 618 even today began its journey toward Earth approximately 10.8 billion years ago, when the universe itself was only about 3 billion years old. For comparison, our Sun is only 4.6 billion years old. The Earth had not yet formed when TON 618's light began its journey. The Milky Way galaxy, as we know it today, did not even exist in its current shape. A faint blue dot on a photographic plate in a small Mexican observatory turned out to be a window into the early universe. A window into a place and a time that no one had ever expected to discover. Before we can fully understand TON 618, we have to understand what a quasar is. The word itself, as we mentioned, is a contraction, quasi-stellar radio source. When quasars were first discovered, they appeared to be star-like points of light, quasi-stellar, but they were emitting strong radio waves which stars normally do not produce, hence the name. But the science behind quasars is far stranger than their name suggests. A quasar is not a star. It is not a galaxy. It is something both smaller and brighter than either. A quasar is the active center of a galaxy. Specifically, it is the supermassive black hole at the heart of a galaxy in a phase of intense feeding. Most galaxies, including our own Milky Way, have a supermassive black hole at their center, but most of those black holes are quiet. Our own galactic black hole, Sagittarius A star, sits silently at the heart of the Milky Way, swallowing very little material. It is dormant. But sometimes, particularly in the early universe, when galaxies were young and full of gas, these central black holes were not dormant. They were actively consuming enormous amounts of matter. Gas, dust, even entire stars were spiraling inward toward them, swept up in the gravity of the black hole. As this matter spirals inward, it forms a flat, swirling disk, the accretion disk. The matter in the accretion disk is compressed and heated to incredible temperatures. Tens of thousands of degrees, hundreds of thousands of degrees. In some cases, the inner edges of the disk reach temperatures of tens of millions of degrees. At those temperatures, the accretion disk glows brilliantly, with an intensity that can outshine every star in the surrounding galaxy combined. This is a quasar. It is, in a sense, the most violent feeding act in the universe. A small region, sometimes only a few light days across, produces more energy than the entire galaxy around it. The accretion disk emits light across the entire electromagnetic spectrum: visible light, ultraviolet, X-rays, radio waves. Each part of the disk emits at a different wavelength depending on its temperature. The energy released is so intense that the radiation pressure can push material outward at incredible speeds. These outflows, known as quasar winds, can travel at a significant fraction of the speed of light. In some quasars, these winds reach thousands of kilometers per second, blasting away the very material that was being consumed. Quasars are also responsible for the formation of jets, narrow beams of high-energy particles, accelerated outward along the spin axis of the black hole at velocities approaching the speed of light. These jets can extend for millions of light years, far beyond the original galaxy. A quasar is, essentially, a black hole eating itself rich. And this is why quasars are mostly found in the distant past. The universe today contains many supermassive black holes, but most of them have already exhausted their available matter. The gas and dust that once fed them has either been consumed or pushed away by the same energetic outflows. But 10 billion years ago, the universe was young. Galaxies were forming. They were rich in gas. The central black holes were not yet starved. They were eating voraciously. The early universe was, by some estimates, hundreds of times more populated with quasars than the universe today. When we look at a quasar like TON 618, we are looking back at this hungry, energetic, formative time. A time before our solar system, before the Earth, before the universe had settled into its current quiet maturity. A time when the dark hearts of galaxies were burning at their brightest. Let us now try, for a moment, to grasp the scale of TON 618. This is, in truth, almost impossible. The numbers involved are so far beyond ordinary human experience that they slip past our intuition. But we will try. The mass of TON 618's central black hole is somewhere between 40 and 66 billion times the mass of our Sun. The exact number is still debated by astronomers. The original measurements, made in 2004, suggested a mass of about 66 billion solar masses. A more recent measurement, made in 2019 by the astronomer Schwer-Ger, suggested a slightly lower figure of about 40.7 billion solar masses. Either way, the number is staggering. 66 billion suns. 40 billion suns. These are mass values that have very few comparison points in the universe. For reference, our Milky Way galaxy is estimated to contain about 64 billion solar masses worth of stars, all of them combined. So a single object, TON 618, has a mass slightly greater than every star in our galaxy, or perhaps slightly less. The error bars on these measurements are still significant. Either way, the conclusion is the same. TON 618's central black hole is, by mass, comparable to the entire stellar mass of the Milky Way. One single object, the mass of a galaxy. Now consider the size. The Schwarzschild radius is the size of a black hole's event horizon, the boundary beyond which nothing, not even light, can escape. For a black hole of TON 618's mass, the Schwarzschild radius is approximately 1,300 astronomical units. 1 astronomical unit is the distance from the Sun to the Earth, about 150 million kilometers. So 1,300 astronomical units is about 195 billion kilometers. Let us place this in a familiar context. The orbit of Neptune, the outermost planet of our solar system, is about 30 astronomical units from the Sun. The dwarf planet Pluto reaches about 40 astronomical units at its farthest. The event horizon of TON 618 is over 30 times farther out than Pluto's orbit. If you place the center of TON 618 where our Sun is, the event horizon would swallow the entire planetary system, the entire Kuiper belt, and reach far beyond it. Light, traveling at the speed of light, would need over 2 weeks just to cross from one side of the event horizon to the other. A single black hole, larger than our entire solar system, and surrounding the black hole and providing its quasar emission is the accretion disk. This disk extends much farther than the event horizon itself, possibly to thousands of astronomical units, perhaps tens of thousands. The total bright region of TON 618 is significantly larger than the black hole itself. When astronomers calculate the luminosity of TON 618, they arrive at another extraordinary number. The absolute magnitude of TON 618 is approximately -30.7. In astronomical terms, this is one of the brightest objects ever recorded. The total luminosity is about 4 times 10 to the 40th watts. In more human terms, TON 618 shines with the brightness of about 140 trillion suns. 140 trillion. Not a million, not a billion. 140 trillion. This is more luminous than the entire output of the Milky Way galaxy, by a factor of several thousand. If TON 618 were placed at the position of the nearest star, Alpha Centauri, only 4 light-years away, it would be brighter in our sky than the noon sun. We would not be able to look at it. We would not even be able to live on the Earth, as the radiation would sterilize the planet. But TON 618 is not nearby. It is 10.8 billion light-years away. So from Earth, even with all that brilliance, it appears as nothing more than a tiny dim point of light. We are looking at 140 trillion suns, compressed in our sky to a single faint star. This is the impossible scale of TON 618. A single black hole, more massive than a galaxy. A single light source, more luminous than a galaxy. A single object, larger than a solar system. And it has been doing this, feeding, burning, shining, for 10 billion years. When we look at TON 618 in the night sky, we are seeing something extraordinary. We are not seeing it as it is now. We are seeing it as it was 10.8 billion years ago. This is one of the most remarkable things about astronomy. Light takes time to travel. The sun's light takes 8 minutes to reach Earth. The light from the nearest star takes about 4 years. The light from the center of our galaxy takes 26,000 years. The light from TON 618 has been traveling toward us for over 10 billion years. When that light began its journey, the universe was only about 3 billion years old. Our solar system did not exist. The sun had not yet formed. The Earth was still cosmic dust, possibly not even gathered yet into the cloud that would, eventually, become our home. And the universe itself looked very different in that ancient time. The galaxies we see today, in their mature spiral and elliptical forms, were still being assembled. Smaller proto-galaxies were merging, colliding, and growing. The space between them was filled with hot, dense, energetic gas. New stars were being born at rates many times higher than today. The supermassive black holes at the centers of these young galaxies were not, like our own galaxy's black hole today, quietly waiting. They were feeding actively, drawing in vast amounts of material, and shining as quasars. TON 618, in this ancient cosmic snapshot, was at the peak of its activity.
The accretion disk was at full brightness. The jets were extending across millions of light years. The young galaxy that hosted it, invisible to us because it is outshone by the quasar, was filled with gas, stars, and chaos. We do not know what TON 618 looks like today. The host galaxy may have grown into a massive elliptical, similar to the largest galaxies we see in the local universe. The central black hole may have continued to grow, absorbing more material, possibly reaching even larger sizes.
Or it may have run out of fuel. The accretion disk may have faded. The quasar may have quieted into a dormant black hole, like Sagittarius A star. We will never know. The light from today's TON 618 will not reach us for another 10 billion years. By that time, our sun will have died. The Earth will have been destroyed in the red giant phase of our sun's death. The Milky Way will have merged with the Andromeda galaxy. The universe will be a vastly different place. This is the strange asymmetry of cosmic observation. Astronomy is, in a sense, a kind of time travel. The farther away an object is, the further back in time we see it. The cosmic microwave background, the most distant thing we can observe, is light that has been traveling for 13.8 billion years. We see it as it was when the universe was only 380,000 years old. TON 618 is not the most distant object we see, but it is one of the most impressive, both for its incredible luminosity and for its sheer mass. Looking at TON 618 is, in a sense, looking through a window into the formative era of the universe. And here is something to consider. In the time it took the light from TON 618 to reach us, those 10.8 billion years, our solar system formed. Life appeared on Earth. The dinosaurs evolved, lived, and went extinct. Mammals spread across the planet. Humans evolved. Civilizations rose and fell. You were born. You learned to read. You found this video. All of that has happened here on Earth, while the light from TON 618 has been quietly, patiently traveling towards us. The cosmos is enormous and patient, and TON 618 has been there the entire time. We have looked at TON 618 in the past. Now let us look forward. How long will TON 618 last? The answer is, in some ways, even more extraordinary than the object itself. Black holes, as we have learned in earlier journeys, are not truly eternal. They slowly emit Hawking radiation, gradually losing mass and energy over astronomical timescales. The larger the black hole, the slower this process. The smaller, the faster. For a black hole of stellar mass, just a few times the mass of our Sun, Hawking evaporation takes about 10 to the 67th years, a staggering number, far longer than the current age of the universe. For supermassive black holes, the times are vastly longer. For a typical galactic black hole, like Sagittarius A star, Hawking evaporation might take about 10 to the 87th years. For TON 618, with its enormous mass of 40 to 66 billion solar masses, evaporation will take approximately 10 to the 99th years. Let us pause on that number for a moment. 10 to the 99th is 1, followed by 99 zeros. In ordinary numerical terms, it is a 1 followed by 99 zeros. To compare, the current age of the universe is about 1.4 times 10 to the 10th years. That is 14 billion years. The age of the Earth is 4.5 billion years. The lifespan of the Sun is about 10 billion years. TON 618 will last for 10 to the 99th years. This is so far beyond anything our minds can grasp that it falls into the realm of pure mathematics. The number has no human meaning. It is the time over which TON 618 will slowly emit Hawking radiation, particle by particle, until finally it dissipates. Most of that time, the universe around TON 618 will be empty. The galaxies will have long since drifted apart, beyond each other's gravitational reach. The stars will have all burned out. White dwarfs will have cooled to invisibility.
Neutron stars will have radiated away their heat. Even most matter will have decayed into elementary particles. But the supermassive black holes will still be there. Patient, slow, dimming, but not yet gone. TON 618 will be among the very last things to exist in the universe. When the smaller black holes have already evaporated, when the stellar mass black holes have faded, when even the average supermassive black holes like Sagittarius A star have dissipated. TON 618 and a handful of other ultra-massive cosmic giants will continue alone in the absolute darkness of the deep future cosmos. There will be nothing to watch them. No galaxies, no stars, no conscious beings. Just the patient, slow leak of energy from these final cosmic monuments. And then, in the very last moment of that incomprehensible time, TON 618 itself will fade. A final, brief, brilliant flash. A burst of radiation. A scattering of high-energy particles into the empty cosmos. And then, silence. The universe will continue to expand. But there will be nothing left to mark cosmic time. No clocks, no motion, no light. Just absolute emptiness, stretching forever. This is the end that physics predicts for our cosmos. The heat death. The complete dissipation of all structure, all matter, all energy. And the very last thing to fade, the very last marker of cosmic history, will be the slow Hawking radiation of objects like TON 618. A faint blue dot on a photographic plate in 1957 that turned out to be the brightest, the heaviest, and ultimately the longest-lasting object we have ever found. A whisper of energy at the end of time. We have come to the end of our journey. We have traveled to TON 618. We saw how it was discovered, by accident, in a small Mexican observatory in 1957. We learned how its true nature was hidden for 13 years, until the discovery of quasars finally explained what it was. We explored the nature of quasars themselves, those brilliant cosmic furnaces powered by feeding supermassive black holes in the early universe. We tried to imagine the impossible scale. A black hole more massive than a galaxy. An object brighter than 100 trillion suns. An event horizon larger than our solar system. We looked back through 10 billion years of cosmic time to see TON 618 as it was when the universe was young, and we will not know what it has become today for another 10 billion years. And we followed it forward.
into the impossible future, where its slow, Hawking radiation will continue for 10 to the 99th years. Far longer than the current age of the universe will be repeated, over and over, before it finally fades. TON 618 is one of the most extraordinary objects we have ever discovered. Not because it is dangerous, not because it threatens us. It does not. It is 10.8 billion light-years away. It can have no effect on Earth. But because it shows us, in one single cosmic example, how vast the universe truly is. How much larger than us. How much older. How much more patient. When you go to sleep tonight, TON 618 is still there. 11 billion light-years away, in the constellation Canes Venatici, just barely visible to our largest telescopes as a faint blue dot. Burning, still, though the burning we see is from 10 billion years ago. The current TON 618 may have grown larger, or quieted, or done both in turns. But it is there, and it will be there in some form for 10 to the 99th years. Long after the sun has died, long after the earth has been destroyed, long after the Milky Way has merged and dissolved, long after every star that has ever shone has gone dark. TON 618 will continue, slowly fading, patient, quiet, a monument from the early universe lasting until the very last moment of cosmic time. And we, who saw it tonight, tiny, brief, brilliant creatures on a small, warm planet, were here. You are here. You are alive in this rare and precious moment, on this rare and precious world. That you can know about TON 618, that you can think about cosmic time, that you can imagine the deep future of the universe, this is itself a remarkable thing. The cosmos is enormous. You are not. But for this one quiet moment, on this one quiet evening, the cosmos has shared its largest, oldest, brightest, and most patient mystery with you. Sleep well. The cosmos keeps watch. Good night.